Hello, welcome to Prepclass Tutors. I am Abel Godwin, and today I'm going to be taking you through some Waec mathematics past questions. And our review is going to be focused on this particular year, 2019. Fortunately, this is the first video in this particular edition. So, just in case you happen to be sitting there, or maybe you have not subscribed before now to our YouTube channel, please, I advise you that you subscribe back to our channel. And if you have not done so, please, this is the right time to do that. So we're launching into our first question in this particular episode. The first question says, express correct to three significant figures, 0.003597. So this question is looking direct, and of course it is. And there are just some little things we need to take note of in order to avoid pitfalls in this particular question. So it is very important to remember that zeros after the decimal place, they don't count before a non-zero digit. So for example now, this 0.00, we don't count them as significant figures. They are actually insignificant. Now, our counting starts from the first non-zero digit, which happens to be 3 here. So this is our first digit, one significant figure, 2, 3. So this happens to be the number of significant figures that we have, 3, 5, and 9. But there's a caveat. This 7 here, we need to round it up to the next number here, which is 9. And on rounding up this 7, because numbers from 7 to 9 are considered as 1, and then 4 downward are considered as zeros. So this automatically becomes like 1. So 1 plus 9 will have something like 10. In another word, you can picture it as 1 plus 59. So this will give us definitely 60. So that is why if you count it now, you discover that this is the first, second, and third. And yes, of course, 0 is significant after a non-zero digit, but not before. It is very important you put that into consideration. So our answer to this question is 0.00360. This is supported by option C. Proceeding to the next question, question number 2 says, evaluate 0.064 raised to the power of minus 1 over 3. So here, we decide to write it in fractional format, as you can see from this to this. So as 64 is here divided by 1, the number of zeros signifies the number of digits here. We have 1, 2, 3. So we have 1, 2, 3 zeros. So in another word, 0.064 is tantamount to 64 over 1000. By the time you divide this, you're going to obtain the same value as here. So we now have our exponent as minus 1 over 3. Okay, working on this now, remember from the laws of indices, when we have an exponential power here that comes in form of fraction, then the denominator will be the nth root of the fraction of the number, and then the numerator will now be the result of which the number or the figure will be powered to. So here now we're looking for the cube root of 64, and that is 4. In another word, 4 will multiply itself 3 times to give us 64. 4 times 4 times 4. And denominator here, the cube root of 1000 is 10. Why? Because 1000 is same thing as 10 times 10 times 10. So we're still left with what? The negative 1 power here. Very important you don't forget. So this implies that we can use this same fraction. Of course, this is equivalent to this because 2 here, 2, 2 here, 5. We can use the same fraction and reverse it. In another word, numerator becomes denominator and denominator becomes numerator. So this will give us 5 over 2. Don't forget, please, if you happen to be in a hurry and leave your answer like this, you will fall into trap. So you will need to remember to swap positions between the digits of the fraction. So our answer is going to be 5 all over 2. And this is option A. You see the trap of option B, which was where we actually stopped before swapping the number. So try as much as possible to avoid this error. So proceeding to question number 3, it says solve y plus 1 all over 2. Yes, this 2 as denominator covers all this. And then minus 2y minus 3 all over minus 2y minus 1 all over 3. So this 3 covers all this also. So the better picture here is something like this. So we have to work on this and find the value of y. Now, first thing to note is it will be ideal if we can clear this denominator because it's making it even look somehow complex. But by the time you use the LCM to clear this fractional denominator, you discover that your work will look simpler. So multiply every term by 6. So the reason is because the LCM of 2 and 3 is 6. 2 times 6 is going to give us 3. So you see there's a 3 and then this numerator. The next here, 6 times everything here. 3 into 6 is going to give us 2. So this is it. And everything about the numerator is well represented again here. And on the right hand side, because we multiply the left hand side by 6, we have to replicate this in order to keep the equality constant. So 4 times 6 also here. Now we just need to distribute this coefficient over the bracket, as you can see. So 3 times y, 3y, 3 times 1, 3, minus 2 times 2y minus 4y minus 2 times minus 1 is plus 2, and 4 times 6 is 24. So now 3y minus 4y is going to give us minus y, and 3 plus 2 is going to give us 5. Then we have our 24. What is left here is just to make y the surface of the formula, and then we are there. So y crosses to this side, we have y, and then 24 crosses to this side, we have minus 24. So 5 minus 24 is going to give us minus 19. So the value of y is minus 19. And this is option B. So going to question 4. Question number 4 says, simplify correct to 3 significant figures, 27.63 square minus 12.37 square. So this is a concept of difference of two squares. Once you remember the expression, the rest is history. So let's look at how this approach goes. Now remember that x squared minus y squared is equivalent to the sum, the product of the sum and the difference of these same numbers. So this is what we call the concept of difference of two squares here. Now, in another word, it means this first number here, let it represent our x, the second one, let it represent our y. So here we have x minus y times we have x plus y. So either of these brackets can come first, it doesn't matter, or that does not matter in this. Now, 27.63 minus 12.37 is going to give us 15.26. Now, by the time we add these two, 27.63 plus 12.37 is going to give us 40. So multiplying 15.26 times 40 is going to give us 610.4, which is roughly 610. And this is supported by option D, 610, and this is the 3 significant figures because y, a 0 after a non-zero digit is significant. So 1, 2, 3, as you can see. So going on to the last question, it says, if 7 plus y is equal to 4 mod 8, find the least value of y. And we're now limited to the value of y, but this y has to be between 10 to 30 inclusively. So we are to add these boundary conditions. Perhaps if it happens to fall on 10, then you should consider the 10. And if it happens to fall on 30, we should also consider the 30. So let's see this. 7 plus y is equivalent to 4 mod 8. From here, you discover that y minus 7 mod 8 is the same thing as what we did here was to make y the subject of the formula. So taking the 7 to this other side, we have 4 minus 7 mod 8. And so this is going to give us minus 3 mod 8. And what this means is that we need to add 8 to the negative number, because in dealing with modulus, we don't need negative numbers. So minus 3 plus 8 is going to give us 5. But if you look at the value of y here, y is 5 doesn't make sense because it is not within this given range. So we definitely need to do something about that. So you are permitted to add the values of modulus as many times as you can until you attain your boundary condition. So here we now have, since y is within this range, the least value of y will be 5 plus 8, and that is 13. So, as you can see, this is supported by option B. With this, we have come to the end of this particular video, and do well to join us on WhatsApp. Prepclass is highly educative and you don't want to lose this opportunity. Until then, we see. Do have a nice day.